Welcome back. In the last session we have discussed about the Poisson distribution concept, the meaning and its concept, and what is the use of Poisson distribution. That was the main aspect we have discussed in the last session. It is a limiting factor of binomial distribution. That means even though binomial distribution has its possibilities, it suffers from some issues with regard to the analysis or study. So in order to overcome that issues, the Poisson distribution concept was introduced. And Poisson distribution is used where binomial distribution cannot be used. That was the main concept regarding that. And we have discussed what is meant by Poisson distribution, and we have discussed some of the cases with regard to that. Let us discuss some of the other cases and how to fit a Poisson distribution. Let us deal with that. Next case. In a certain factory turning out optical lenses, there is a small chance of 1 by 500 for any one lens to be defective. The lenses are supplied in the packs of 10 each. Use Poisson distribution to calculate the approximate number of packets containing no defective, one defective lenses in a containment is 20,000 packets. So in this question they have specifically mentioned that you need to use Poisson distribution to calculate the approximate maximum number. Usually in the university question they may not specify the method which we are dealing with. It's up to your logical sense to understand whether the given question or a distribution related to a binomial distribution, Poisson distribution, or normal distribution. We will discuss about normal distribution in next sessions. Right now, here it's a case of a Poisson distribution, so we need not have to go further digging about that. The question it is said that a factory is dealing with optical lenses. I hope you all know the meaning of optical lenses. And I hope you all know, you will be having an idea about lens. You have seen different types of lens or different kinds of lens, so we need not have to go further into that. Okay, the factory dealing with lenses, there is a small chance. From that term itself we can understand that it's a case of a Poisson distribution, because Poisson distribution deals with the analysis of events which are having a small chance of possibilities. And there is a small chance of out of 500 items, one may be defective. That is a small chance. For any one lens to be defective, the lenses are supplied in the packets of 10. Here 10 is given. Use Poisson distribution to calculate the approximate number of packets containing. Here are given two questions. First one is there are no defective items. Second one is one defective item. And here it is mentioned that a consignment or a packet consists of 20,000 items. So in the question 10 items also given, 20,000 items also given. I hope you know the difference between 10 and 20,000. 10 represents small n and 20,000 represents capital N. So let us extract the data given in the question, then we can directly substitute those in the equation. In the question it is mentioned that lens supplied in a packets of 10, and I have mentioned that small n equal to 10. And in the question it is said that, it is specifically mentioned that probability of a defective lens is 1 by 500. So the probability of a defective lens is 1 by 500, which can be written as 0.002, which is known as the mean, or m. We have got the m value. We need not have to go further about finding out the m value. From the details given in the question itself, we have found the value of m. M means e raised to minus m. I hope you know how to find the value of e raised to minus 0.02. If you have any queries, please let me know. So the value of e raised to minus 0.02 is 0.9802. It will be constant with regard to the particular question which you are dealing with. In the previous questions also we have discussed different times. Once you find the value of e raised to minus m, that value will be permanent depending upon whatever the nature of the question. Even if you have to find for 10 items, here in this question you have to find for only 2 questions. One is defective and another is not defective. If you are given a question where you need to find answers for 100 questions, the e raised to minus m will be the same. Okay, in this case we have found the value of e raised to minus m. Next, m equal to n into p, that is 10 into 0.002, that equal to 0.02. This is how you have got the value of m. Because we already found the value of n, here it is 10 is given, and the probability is also we found out 0.002. So m equal to n into p, that is 10 into 0.002. We have done that step numerous times in the previous sessions. So we have found m, and we also know how to find the value of e raised to minus m. Let us go to the main part. In the question, as per the Poisson distribution, the Poisson distribution function will be like this: p of x equal to e raised to minus 0.02 into 0.02 raised to x divided by x factorial. If you remember the equation, you will understand why we are using all these values here and there. This is a main common distribution function equation, and in the question it was said that you need to find the probability with regard to Poisson distribution case where no defective goods are found. So no defective means the value of x will be 0. So p of not defective means you have to write it as p of x equal to 0, and the same Poisson distribution function is also taken here where x, the value of x will be 0, because we are dealing with first one no defective goods, that is x equal to 0. E raised to minus 0.02 into 0.02 raised to 0 divided by 0 factorial, you will get 0.9802. So that is the probability with regard to no defective goods. So that is the value that represents the probability of no defective goods. So what are the number of items with regard to that? It can be found by the number of packets containing no defective lens is 20,000, that is capital N 20,000, into the probability of no defective goods. Then you will get the exact number of items that are representing no defective goods. So this is how you have to deal with a Poisson distribution case, where you have to find the number of items based on the particular probability of that scenario. So here the value is 919604. So out of 20,000, 19,604 will be non-defective goods. Non-defective, not defective. So first part is over. Second one. In the question it was said that second part is one lens will be defective or one product will be defective. So probability of one defective can be written as p of x equal to 1. That is equal to same Poisson distribution function is taken here, where the value of x will be 1. Here it was 0, here it is 1, because here x was 0, here x equal to 1. E raised to minus 0.02 into 0.02 raised to 1 divided by 1 factorial. You solve it, you will get a value this. This is the probability of occurrence of one defective goods out of 20,000 packets. So what is the exact number of items? It can be obtained by just multiplying the total number of items, that is 20,000, into whatever the probability which you have found now. You will get the value of exact number of items of one defective lens. So the number of packets containing one defective lens will be 392 pack items or 392 packs. So this is how you have to deal with application level questions with regard to Poisson distribution. So you need to first of all find the value of m. M may be given directly or indirectly. We have discussed some of the cases in which the m computation we have found out. Once you find the m, you need to find the value of e raised to m minus m, and after that, depending upon the nature of the question, you need to substitute the necessary data in the equations. So I hope you understand the concept. Let's go to the next one. Comment on the following. For a Poisson distribution, mean is 8 and variance is 7. Is it right or wrong? That is the question. For a Poisson distribution, mean is 8, variance is 7. Is it right or wrong? We have learned that the mean and the standard deviation or the variance of a Poisson distribution is always same. The number will be the same, value will be the same. But here the mean is 8 and variance is 7. And in a Poisson distribution, we have learned that mean is always equal to variance. In this given information is here a Poisson distribution detail where 8 and variance 7 is given. Here the variance and the mean are not equal. You can see that one is 8, one is 7. So the given statement is not a Poisson distribution. So sometimes you may come across a question where you need not have to use a calculator or mental calculation to find the answer. For that you need to aware about the properties with regard to each of these cases. We have gone through briefly regarding various properties, and we have been discussing some of the main properties during the application level cases. Until then, you need to thorough about the properties. Sometimes you may come across questions like this. So I hope you have understood the concept until now. Let us go to next area. Fitting a Poisson distribution. We have learned about a similar type of topic during binomial distribution. It is almost similar to the same concept. In binomial distribution, we have learned about fitting binomial distribution, where you will be given details regarding a random experiment and its events. Along with that, you will be given details of the actual frequencies or actual events. On the basis of those details, you need to find the expected frequencies, otherwise known as theoretical frequencies or distribution. And we have learned about the steps that are required in case of a binomial distribution. In case of Poisson distribution, the concept is also similar like the binomial distribution, where you will be given details regarding an event or random experiment or random variables. In simple terms, we can say it as you will be given the values of x, and associated with the random variable x or events or experiments, you will be given frequencies. Frequencies means actual repetition of that event. Actual events or actual distribution or actual frequency distribution will be given. On the basis of these two values, x and f, you need to find the expected frequencies or theoretical distribution frequencies. That is the concept. And with regard to Poisson distribution, you will be using mainly Poisson distribution function equation to find each of these expected values. That is the theoretical concept with regard to fitting a Poisson distribution. So let us go further into that. If we want to fit a Poisson distribution to a given frequency distribution, given frequency distribution means you will be given x items and f items. That f distribution is known as frequency distribution, otherwise known as actual frequency distribution, actual details of the events. We have to compute the mean of the given distribution. We all know that we have to compute mean, because for Poisson distribution you have to compute the value of mean and take it as m, that is the e raised to superscript minus m. That m is known as this m variable. Once m is known, the Poisson distribution is obtained by putting that value of m in p of x raised to e raised to minus m into m raised to x by x factorial. We know this equation. This is a formality with regard to the theoretic concept of fitting Poisson distribution. The expected frequency can be obtained by putting the value of x will be given in n. If you multiply n with this equation, you will get the actual frequencies, just like the method which we have just done now. I hope if you remember the lens case, the case or the problem with regard to the case of a lens, where you found the probability of defective and non-defective ones, and once you found the probability, you need to find out the actual number of items. For that, you multiplied the probability with the n. Similarly, once you find the probability or with regard to the Poisson distribution of each of the events, you need to multiply it with n. That is written as here, n into whatever the probability value you have obtained by using this particular Poisson distribution function. That is the concept. Just like the method which we have learned case of a binomial distribution, the only difference is that In binomial distribution, we use binomial distribution function or equation or formula. In case of Poisson distribution, we have used Poisson distribution formula. That is the only difference between these two cases. So let us go further into that, then you will get a clear idea regarding the Poisson distribution situation. A question: systematic sample of 100 pages was taken from a concise Exophoria dictionary, and the observed frequency distributions of foreign words per page was found to be as follows. Calculate the expected frequency using Poisson distribution. Also compute variance of fitted distribution. So in this question, details regarding a certain dictionary is given. The thing is that out of 100 pages in a specific concise Fourier dictionary, it's type of dictionary, and its frequency distribution of foreign words per page also is given. Calculate the expected frequency using Poisson distribution. So out of 100 pages, the number of foreign words, usually in a dictionary, English Malayalam dictionary, we will have English and Malayalam words, or English Hindi dictionary, you will have English and Hindi words. Likewise, in a concise Exophoria dictionary, you are asked to find the probability of foreign words, chance of occurrence of a foreign word. So in this case, 100 pages of a certain dictionary, concise Exophoria dictionary is actually a dictionary with regard to a medical field, and its observed frequency distribution of foreign words per page is given. That is, if you in 0 pages there will be 48 frequency, chance of occurrence of foreign words will be this one, and in case if it is one page, number of foreign words in one foreign word, you will be looking for the frequency of occurrence of that one foreign word will be 27% chance, and in case of 2 foreign words, the chance of frequency occurrence will be 12. Likewise, 0 to 6 is given, and in the case of 0 means none foreign words, the occurrence or frequency of occurrence of a non foreign words is 48. Just like that, 0, 1, 2, 4, 5, 6 like that, and its corresponding frequency distributions is also given, and out of which you need to find the theoretical distribution with regard to this particular case using Poisson distribution. That is a concept regarding the question. So number of foreign words per page is given, and the frequency of occurrence of foreign words per page is also given. So first of all, whenever you are dealing with a Poisson distribution case, you need to find the value of m or mean, and we all know how to find mean. Here x and f is given, so you can easily find the value of mean using the basic mathematical methods or computation of arithmetic mean. So at first we have to know the parameters of Poisson distribution, which is equal to the mean of the given distribution. So the mean of the distribution, we know the equation that mean of the equation, mean of whatever it is, sigma fx by sigma f. Since it is a case of x and f situation, discrete series, sigma fx divided by, we have learned that sigma fx divided by capital N. Capital N means total of f. If you add all these values, you will get value 100. That is the meaning. So x is given, f is given. If you take the total of f, that is known as capital N, you will get 100. It is already given in the question. Next one, fx. Instead of writing in column vertical form, I am writing in a horizontal format without any tables or columns, because these are the basic methods which we have learned in the previous semesters. So fx you need to find, just multiply f into x, you will get the corresponding multiplication value of each of the columns. So once you find fx, just take the total of fx, that is sigma fx equal to 99. And the mean of the particular case is mean equal to sigma fx divided by sigma f. And here it is, fx is given, sigma fx is 99. So sigma fx divided by sigma f is also there, 100. So the mean of the particular distribution is 0.99. So we have found m. Once you find m, you just find the table value with regard to e raised to minus m. Here it is 0.99, so it will be e raised to minus 0.99, and find the table value of that particular number. Once you find the table value of the particular number, you need to find the theoretical distributions on the basis of the x values and the actual details or actual frequency distribution, otherwise known as observed frequency distribution. Actual events, once we observe the actual events, it is known as observed frequency distribution. These are known as observed frequency distribution or otherwise known as actual distribution, and on the basis of this actual events you need to find expected frequency. So let us go with the expected frequency situation. Continuation. Mainly 3 columns. First column we can denote it as x. Second column, let it be probability of particular x value, and finally expected frequency that we have to compute as per the question requirement. And first column will be x. We know that the value of x 0, 1, 2, 3, 4, 5, 6, 7, likewise it is going on until 6 is there in this case. And for finding the probability of x, you need to use the equation e raised to minus m into, here it is, there is a multiplication sign, you can use it or not, e raised to minus m into m raised to x divided by x factorial. This is the equation with regard to Poisson distribution function. And next one, expected frequencies, that is n into p of x. First one, let us begin with the first value, x. First value is 0. So we all know how to deal with that. Just substitute the 0 in the particular x positions. E raised to minus m, we have already found the value of minus 0.99 into m raised to x. M is 0.99 raised to x. Here the value of x is 0. Divided by 0 factorial, you will get 0.3716. So we have got the probability with regard to the event, that is 0. So in order to find the number of items in numerical terms means in number of times or number of items, or in simple words we can say, in order to find the expected frequency, you need to multiply the probability of particular event into n. In this case n is 100. So 100 into 0.3716, you will get 37.2. So number of times, as per the expected frequency, the number of times foreign words comes. Here 0 for the frequency and the expected frequency for 0 occurrence of foreign words is 37.2. That is the concept. Then you will think that what is the question, that is details given regarding the frequency in the question. That is the actual events occurred. This is the expected value that can happen or not. That is the concept. We are asked to find the theoretical distributions. We need to know this theoretical distribution to know further analysis with regard to another similar experiments. That is why we are finding that. Next one. When the value of x is 1, actual value of x is 1 is just almost similar to the methods which we have done previously. You need to substitute the value of 1 in whatever x areas has come. Here it is e raised to minus 99, it will be saying 0.99 raised to x, that will be 1. Here also x factorial, here it is 1. So the value is 0.3679. So you need to multiply it with n. 100 into 0.3679, you will get 36.8. Next one, the value of x is 2. That is equal to e raised to minus 0.99 into 0.99 raised to 2. That is em raised to x, here it is 2, so it is 2 divided by 2 factorial, you will get 0.1821. Once you multiply 100 with 0.1821, you will get 18.2. Next one, when the value of x is 3, the only change happens is whatever the x variables, it will be changed to 3. So 0.99 raised to 3 divided by 3 factorial. If we solve that, you will get 0.0601. I hope you all know how to find 0.99 raised to 3. Just multiply 0.99 3 times. And 3 factorial also, I hope you all know how to find the factorial concept, because we have learned about numerous cases previously. Once you find the probability, just multiply it with the n. Here in this question, n was 100, you will get 6. And next one, 4, just like the similar step which we have followed previously, 0.99 raised to 4, and here it is 4 factorial, you will get 0.0149. Just multiply that probability with 100, you will get 1.5. Next one, when the value is 5, it can be written as e raised to minus 0.99 into 99.99 raised to 5 divided by 5 factorial, you will get 0.0029. If you multiply it with 100, you will get 0.3. And finally, it is 6 e raised to minus 0.99 into 0.99 raised to 6 divided by 6 factorial, you will get 0.005, which can be written as 0.1. So now we have found the theoretical distribution of particular case by using Poisson distribution. So in this table, the theoretical distribution we found are the values that are shown within the red lines. So whenever you come across a question like this, once you find the expected frequencies, please note it down separately. So these are the known as theoretical distribution or theoretical frequencies or expected frequencies. You are asked to find this one on the basis of actual values. That was a concept with regard to fitting your Poisson distribution. And in the question it is also mentioned that you need to find the value of variance. I hope we all know the value of variance, because as per the Poisson distribution concept, the mean and the variance value is almost same. And we already found the value of mean, that is 0.99. So the variance value will also be 0.99. So this is how you have to deal with a Poisson distribution case. And remember the various properties, features and theoretical aspect with regard to Poisson distribution, and also familiarize the cases with regard to Poisson distribution. We will discuss about the next type of distribution in the next sessions. Until then, go through all these areas. If you have any queries, please let me know.